Hi guys, my name is Preece. I work at Readify as a senior consultant, generally in backend and DevOpsy stuff, which is what a lot of this talk is about. My journey from about 10 years ago when I understood very little JavaScript to getting a sudden shock about 6 months ago when I had to learn it very quickly. So I've been in this industry doing .NET work for about 10 years. I started off as a Silverlight WPF developer. People who are crying, we can all remember, right? Some of you in here, please? Okay, it's just me. That's all right. So I've done it for 10 years. I've started out as a web developer a very long time ago, moved into app dev, and then started doing consulting. Now, because this is the D&D slides, we still have the sponsors. Let's ignore those, because PageUp isn't even on there. Now, who's this talk for? If you're a JavaScript guru, it might be a good time to leave the room. I'm sorry, this probably talk is not for you. But for the rest of you who are still kind of scared by JavaScript or tried to learn it and failed miserably because they assume a little bit of knowledge, you probably feel a bit like this. You have JavaScript, you're going to siege a castle. You spend hours picking libraries, setting up Node, building a framework, and by the time you're finished, the fort has been abandoned and the princess has moved to another castle. Everything is a mess. No fun. The JavaScript system, as I knew it, is now unrecognizable for me. I left in 2010 when jQuery was king. Who remembers those days? My people, yeah, all right. So I remember when jQuery was king. I downloaded the file, that was all I needed, and off I went. I'm a JavaScript dev now. I walked away. I came back in 2018 to an exceptionally different and scary place. Frameworks, build tools, transpilers, task managers, package managers. It was very hard for me to pick up. And I assume this for you guys too, who've been away, because they assume a little bit of knowledge. In fact, a lot of knowledge. So this is me. This is my journey and what I learned along the way. Rah, 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 rah. So what I'm going to take you through is the dark ages to now. So we're going to start with a bit of ye old JavaScript, element by ID, all that kind of stuff, with a website like this, and we're going to take it into the future, one tech at a time, so you can learn, like I did, why the things we have now exist the way they do, which for me was a fundamental way of understanding which way to go to next. So, before the beginning, before web, we had ye old JavaScript. The very, very basics. 90s JavaScript. If you're having PTSD, I sincerely apologize. If you're young, you may never experience this true horror, which you're even luckier. So all this code is doing is right now we have a script.js, which is just our HTML. We reference our single file, and then we start with a very plain, simple JavaScript vanilla language. We attach the window, call an unknown event, call a function to attach to that event, find a document element called SP, get the current date, and then append some inner HTML inside it to update the DOM. Nothing hard. We end up with a page like this. You get a basic page, and we append to it current day is 6. We're old JavaScript, so we can't even do days properly. Yuck. That's what we got. Nice and simple. Then we enter the dark ages. In the early to mid 2000s, a scary and horrific time where IE6 ruled the world and frightened small children. When we want to use jQuery or other libraries of the time, we just download them. So we get our files, put them in a local directory, add them locally and reference them. You all probably know how this works, but it's a good refresher. So we took our jQuery file, took our moment file, threw them in our local directory, off we go. We FTP that up, yay. We use some jQuery stuff, $, being the jQuery symbol, ready function when the DOM is ready. We now can use moment to get some proper dates, and we append using jQuery. Pretty straightforward. Now, not much of the sample code is going to change. So the actual language itself hasn't changed that much. We still do very much the same thing. What's going to change is our interpretation and management of how we do these things. But hey, we do this, we run it, and it looks very much the same. Except now, we have a current date. So we know our library is now working. So that's great. However, personally, until a few months ago, this is where my knowledge stopped. I left the game at this time. I went to do app dev thinking that WPF and Metro and WinRT would rule the world. I still use Windows Phone for 7 years. I believed in the dream. But I became this. I came back in 2017 and I felt like a dinosaur. A lot had changed. I struggled to understand why things were the way they were. I didn't understand why Webpack existed, why Node was so important, why React was so important. It just... So I'm going to take you through 2010 to 2018. So from jQuery to now. The first thing we start with is the brave, exciting new world of package management. NuGet for frontend, basically. As we learned in .NET development, downloading files piecemeal is not a particularly pleasant or nice experience. We decided that placing files ever was a bad idea. CS Proj didn't get that idea into .NET Core, but we still had this idea that placing files ever is bad. So when we started to use JS for backend stuff, Backbone, not particularly Backbone, but Node.js in particular, we started to use JavaScript on the server where we couldn't really manage it this well. So we introduced package management. In 2013, Bower was the new hotness, and NPM was the backend. In 2015, NPM knifed Bower in the back, rather unceremoniously, and NPM now rules the world. Now, the reason for this is quite interesting. Historically, you required Bower to install, NPM to install Bower. So it was deprecated by lazy, efficient developers who decide one package is better than two. But hey, this introduces a nice way for us to download and version our library, so when jQuery goes from 3.3.1 to 3.3.2, we can easily do that by pressing some command and not missing a file or missing a security patch or whatever else. A warning to you all, but none of you care, you are developers, this is fine. The biggest change to any of these tools was command line. We had a seismic shift in 2013 away from web dev being something anyone could pick up to something where you required a modicum of command line skills to make work. So learn to love it. I'm sure you all do, but just in case you don't, you may want to, cry. Ugh. So we started using Node to get packages. NPM, Node Package Management, was 3 simple commands to do what we just did. We do npm init to build up our local file system for package management, and we install and save jQuery in moment. So instead of downloading them, we do it this way. That looks something like this. We type in npm init, we get a whole bunch of commands because it's really helpful and easy, and we just keep pressing enter and typing the things we want to type in. Give it a description, an entry point, test command, an author, if you want to put your name to it, if you're not too embarrassed, and it will tell you what it's about to print out. All this is building for us is a package.json file, which is kind of like our packages.config, if you remember that from old NuGet, or now in our CS Proj files in .NET Core. We then go ahead and install our libraries, and all that does is just download files directly. Nice and simple. What that actually does in our package.json is very similar to how NuGet would function. It builds a file and adds in just these dependencies. This thing uses what we call semantic versioning, which is a bit scary and outside the scope of this talk, but essentially it's a way of specifying certain versions you'd like to use. So I want to use major, minor, where am I allowed to go to, that kind of thing. That's important about that. So all we have to do now, we've got our files, got some packages, we just replace them with our downloaded files. So we reference node modules, which is where they're downloaded to, find the various parts, and call it a day. This is still kind of yuck. We're still referencing files, it's still unpleasant. We can get lost, maybe we copy paste something and don't realize that just because jQuery has a dist function doesn't, or folder doesn't mean moment does. It's not great. So we move on to the next level, which was modules. So the next step in JavaScript development excuse me, was to remove the file referencing entirely. But before we go into that, I want to give a bit quick reference about modules, because modules are a little bit different to the rest. In 2009, CommonJS, a project, is born. The big killer app for this thing, many other things it did, but the big killer app was the ability to define modules. And Node.js is now the most well-known and arguably the only standard we care about of modules. The takeaway is that modules allow JS to import and export code across files without resorting to globals like we used to in the dark days. So we can just basically say require XYZ, and we don't have to worry about loading them to globals or worrying about storing them in some way. It'll just do it for us. Which is fine for our backend, but our browser doesn't understand easily our server frontend. So we can do async and other funny things to try and download files from a file system server, but let's not do that. It's big. But before we do that, let's see how this all works. So this is the code change when we're using modules as opposed to referencing files. All we've done here is we get rid of the referencing files. So now we're just back to our major file again, scripts.js. And now we do this funky require syntax. So $ and moment are the two variables that jQuery and moment libraries use. We require those, and everything else works as before. However, try this on a browser and you will get this nice little message that will make you sob. Require is actually a Node.js specific function. The browser doesn't know how to implement this. So if you try this in the browser, this is Firefox, but you cool kids may use Chrome, it will give you requires not defined. And we cry. Bundlers are what rescue us from this mess. Specifically, you may have heard one of these as the scary thing that lurks under your closet and attacks you when you're asleep. I'm talking, of course, about Webpack. But before I get to Webpack, in 2011, we had Browserify. This was the original gangster of module bundles. It pioneered the use of require statements on the front end. So Browserify, it's not very relevant now. You may find it in a legacy project, but it exists to teach you, or it exists to allow Node packages to be used and replace Bower as front-end tools. Then we got Webpack, which you've probably heard is the stuff of nightmares. Lately it's been my nightmare. But it's not that bad. It's just very powerful. And bad people can do bad things with it. It does module bundling, and a whole lot more than that. And that's where the scary part comes in. It's really better to think of it as a build chain, as opposed to a moduling tool. So make, cake, rake, MS build, whatever your tool chain of pain choice is, Webpack is very similar to those. The most common task it does is transforming source code, which is done by a loader, so turning something into something else, or plugins, which do minification, uglification, ification here. What if you want to do those two things, generally are the categories we fall into. Now for me, when understanding this, this was my big light bulb moment. This is where it all clicked for me and I started to understand the things I've been missing all this time. And if you want to take anything away from this, this is the big one. Bundlers make NPM possible for front-end modules. So bundlers go in, see the require statement, and replace it with the inline code of the JavaScript that we would have been referencing using the require function. So all it does is build a big giant JavaScript file with all the things that we were referencing inside it. That's all it does. So that require function that we use in our code when we're writing Node or Webpack code doesn't actually get called in the browser. It doesn't exist. tools like Webpack or Browserify remove it and shove in the code you're using inside that. That's when things click for me. To understand that in order to use this package manager, you must use a bundle. So how does that look? You run the fun command of install Webpack. This is sped up about 3 times because installing Webpack takes roughly an age. But what it will do is it will go through, build a whole bunch of things, and add, just like adding jQuery or something else to our modules directory. The only difference is this save dev idea. So developer dependencies are things that Node will reference in its package.json that will be used to build something, but are not actually bundled in at the last stage in production builds. So these are the things that we would like to use as a developer, but not exposed in the front end in our production builds to our customers or clients. So Webpack, Webpack CLI, and other things like that are what we call dev dependencies because we don't want to keep them in our client side. Using that is just a simple case of writing this excruciatingly long command, this one here. You call Webpack as a binary, you pass it your script file, you give it a mode, in this case development, and it spits out stuff, which we care about. But what this really means is that it's bundling into a dist/main.js. You can actually supply it to change it to some other name, but by default, it will build distribution main file. So again, it's like compilation. JavaScript has gone from adding a file into your web browser to building a bunch of files into one file. Make sense? Cool. So all we now do is reference the mega file that we had before instead of our own file, because that main file we had that we dev with had the require statements. This new mega file that Webpack has built has the file and the resolves inside. Now, that command is kind of messy, so if you want to run something else, or run it just by going Webpack start with this command here, without the arguments, we build a webpack.config.js file, which is just this export JSON of arguments we'd like to attach to Webpack to run. This, when people tell you they're having Webpack nightmares, this is the file they're generally referring to, because this is a very long, this can get very long, very scary, and there are like thousands of options. But for the meantime, for our purposes here, all we've done is compared, we've taken our arguments here, so scripts.js, mode development, and added them into here, and defined our distribution file. So it makes sense. You just got to read it logically and understand where things are going. So that was a big thing for me, understanding this Webpack and why we have it and why it's even a thing. I struggled with that. But then that wasn't enough, and this is a bit messy. So we decided to go for our modernizing stage. And this is really one of the last phases of JavaScript. If you understand this, you're pretty in the green. So this is to build up a compilation and build system that really makes JavaScript more of a modern dev tool than a toy it used to be in the 2000s. So first up, we have this thing called transpiling, which I like to think of as development witchcraft, because we can convert one language into another similar language, which means, in essence, we can write JavaScript in a language that is not JavaScript, which makes me very happy, because, JavaScript. Considering I stayed away from web development due to IE6 requirements, this was pretty big for me. I lamented using JavaScript in 2008, 2009, because everything I wrote had to work in IE6, which meant I couldn't use any cool new stuff. I was stuck using old stuff, or things that hacked around it, which wasn't fun for me. So that's one of the reasons I left. Coming back to find this was really cool for me. We developed a few transpiling tools. CoffeeScript was the first one in 2010, which I admit I was aware of when I left web dev, but didn't quite understand what it did. Essentially, it added some language features to make JavaScript more pleasant It's not really in vogue now, but it was the first. In 2015, Babel came along, and Babel was the big heavy hitter. It is designed to transpile new age JavaScript into something like IE 10 or above can understand, which means you can spend your time writing cool async await and other things without dealing with old browsers. And you have TypeScript, which is, for our purposes, written by or designed by the same people who designed C#, so it shares a lot of similarities with that, which means we can use types in compile time checking and IntelliSense with a language and still get output that works in old IE browsers and old Firefox, Chrome, Safari, whatever. Remember, this is witchcraft. As far as I'm concerned, this was amazing to me. I love the idea that I can write JavaScript and not have to deal with JavaScript. One side note. You may hear the terms ES5 versus ES 2015 tossed around. ES5 is what we all know and hate. I mean love. It's compatible with anything that calls itself a JavaScript client. Internet Explorer, Raspberry Pi, iPhones, Android One, whatever, ES5 will work. ES 2015 is the future. So many new things that I could run an entire day workshop on it by itself and you still wouldn't know it all. But the most important thing to know, the reason why it makes it so important, is modules and proper async handling. So again, we had this required module statement. New JavaScript supports modules up front, so the browser can deal with them. And async handling, so we may have heard things like promises in the past. They're like .NET tasks, but we can use async handling with them in new JavaScript. So it's much like writing C# or even VB if you're so tortured. So with Babel, we can write, or TypeScript, we can write ES 2015 code that will be ES5 compliant. Ta-da! Using Babel to support new features is just like using Webpack. We find the magic incarnation to install it. And trust me, when I wrote this talk originally and then came back to look at it 2 weeks later, this command had changed. So that was fun. I don't even know why, but it works now. So we install Babel, we install some things into the save dev instruction here. And that will do the exact same thing as Webpack, install it into our package.json as a dev dependency. And then, inside our Webpack config, we add this stuff, which is looking very scary. But all this is doing is saying, in order, we have a module, here's some rules. When you see a JS file, excluding node modules, which has thousands of JS files, I don't want to run those. I want you to use Babel loader with the preset environment preset plugin. So all this is doing is saying when you run Webpack, I want you to go find all the JS files, pass them into Babel, and run this preset env which tells Babel which standard to target. By default, it targets ES5, so by running this, we will turn our ES 2015, 16, 17, 18, whatever code into something that is ES5 compliant. Simple? Clear as mud? Awesome. Now with this stuff in place, we can actually use some pretty interesting stuff in new JavaScript. So like I said, there's not much has changed. It still looks pretty much the same. The two things I want to point out is that now we can use proper importing syntax. So instead of using this weird require function, we now have an import variable from module. So we can do that. The only other thing that's changed here is down here, where we can now use string interpolation like we can do in C#7. The only difference and what the gotcha is that it may not be able to see it from the back, but this is a grave, which I can't draw on because I'm zoomed in. But anyway, this fun thing back here is a grave. If you don't do that, it will complain and do nothing, which is unpleasant. So that's the only thing to keep in mind. Like us in C#, we put $1 in front. In JavaScript, you just put grave symbols as opposed to quotes. And now we get new features. We can use that in any browser with Babel and carry along our merry business, which is great. as one last nice little I'm really sorry, excuse me. As one last little tidbit, using TypeScript is pretty much the same as any other dev tool like Babel. We install it, we give it a loader, because you saw before Babel had a loader, now we need TypeScript's loader. And we need to do this at typesing. This thing here. Now, as I mentioned before, TypeScript is a language that provides type checking and compile time static checking to JavaScript files. So we need to provide it saying, hey, by the way, TypeScript, here's the type definitions for these JavaScript modules. And someone over in the definitively typed GitHub maintains a whole ridiculous list of modules and their typing, so us TypeScript people can use it without crying too much. The problem comes with TypeScript. If you want to learn it and get into it, if you ever develop a module that does not have a typing, you must do it yourself, or you'll be in a world of pain. That's the trade-off. But if you're lucky, and just like things like jQuery and Moment, they will give you typing, so we can start doing things straight up, which looks a bit like this. You may have noticed so far that I've used GIFs and slides in all my code examples because demos tend to blow up in my face. However, because it's funny, we'll try and do one off the bat, just to show TypeScript very quickly. So, let's get a bit more zoomed in here. And we'll get the mouse over here, and okay. So, one more zoom. No, too bad. You all see that? We're happy? Fantastic. Okay, so this is the same repo I've been showing you throughout this entire demonstration. The only difference is this is the TypeScript enabled branch. And in the Git repo at the end of this talk, every slide has a branch so you guys can step through the various code changes that I've made so you can see the journey from one to the other and how that works overall on the project, if you so desire. Now, all that's different here, we have a TypeScript config, and our file is now called script.ts, TypeScript. Now, as you can see, this doesn't look incredibly different from our old ES6 or ES6, ES 2015 code. But what's changed is we now have IntelliSense and types and other things that we get from the typing system we installed. Which also means if I am reckless and misname this function, it will tell me about it and say, this isn't right, did you mean this? And I can fix it in a Roslyn-like tool and that kind of thing. So, along with a TS linter, a TypeScript linter, we can check for errors and other things. So for me, this was pretty big for me. I'd go ahead and I would install something and not quite know what I could do with it. So in this case, I'm like Moment, if I press Control Space like I would in a browser, I can start seeing all the things I can do and what they mean to me, what the things are and so on. This is still a JavaScript enabled language. If I use TypeScript loader and Webpack over this, I will get at the end completely safe ES5 code, which I thought was pretty cool. That's it. Very simple demo. Nothing to tempt them too much with. Okay, bonus round. Task runners. Now, we've seen all these cool tasks and tools and so on, but remembering commands like we're doing Kubernetes development is not all that fun. So in 2013, we come up with Grunt or Gulp, two competing things that did essentially the same thing. And what they did is they automated the tasks we'd use in the build system via command line tool wrappers. 2015, NPM said, stuff that for a joke, we're going to call them directly. So instead of having JavaScript wrap the command and broke all the time, now we just call the commands directly, which is great. It means you can do things like this. Terribly sorry. So again, in our package.json file where all our node things live, we can add in commands that we can run that will do things for us. So in this case, we've added in a build command, a watch command, and a server command. Now in server, I've actually installed another thing called Webpack dev server, and I've installed that beforehand as a save dev dependency, and then called npm run whatever. So really, all this is doing is allowing us to go ahead and, for those who can't see that at the bottom, it's just a simple command, nothing too drastic. Please don't fall over. Oh, reckless. So when we run a command, we can call this anything we want. We can call this npm run I hate you, and it will run tests and break. Who knows? You can call it anything you want. What this means is that we can start training some particularly long, gruesome commands in our build package that gets shared between developers in our team, and can start automating some pretty unfun build tasks, and also use them in our CI/CD when we start deploying these things, going, hey, instead of deploying this giant script with all these commands in it, I'm going to deploy one command that actually calls a bunch of other npm commands that actually does a whole bunch of other things I want to do. So you can train these things up. Now, Webpack dev server is a nice little tight custom express, which is a Node.js web server that will run things like hot module replacement and other things. Hot module replacement is this really, really cool thing that breaks a lot, but when you get it to work, it will allow you to open up your web page, change a bit of JavaScript, and reload that JavaScript in real time without refreshing your page. So in a lot of these new age JavaScript apps, we want to keep a lot of state. And it's really annoying, and we do this in .NET too, to have to restart our server to go back to where we were just to see if our code change worked. With Webpack dev server, we can watch the JavaScript files changing, we can make a change, it will see it in the browser, and update just that bit of the code that's been affected so you can keep the state. It doesn't always work, but it is a great time saver and something we can just run by doing npm run server, which goes back to Webpack dev server. You may have noticed there's a lot going on here. Things have definitely changed. But this is the current state of modern JavaScript development. There are a ton of moving pieces, especially if you're a beginner. When you got into web dev, like I did as a student in the mid-2000s, you didn't need to learn a command line tool or any of these esoteric systems. You just drag the file in, hacked away, and called yourself a web developer. Now, no such luck. However, there are modern frameworks such as Angular, React, or Vue, however you'd like to pronounce it, that come with command line tools to scaffold a lot of this for you, which can be a blessing or curse, but for most people it's a blessing, because we can just type one thing and away we go. Which, since in my talk abstract I did promise you I'd talk about a bit about React, so I'll wrap this all up and explain what this all means with a very quick tour of a very complicated framework. So, React uses all the tools that we've spoken about already. We use npm to install it, we use Webpack to bundle it up, we use Babel or TypeScript, if you're brave, to support ES 2015. We use task runners to support the smooth build experience to make sure these things work together, and a command line tool, create React app, to get us started and scaffold all this out for us without having to learn all the pieces that just came before us. Looks a bit like this. We run this command, which I'll zoom into, called npx, which is just node package execute. So basically we're saying, I want you to download this package and run it, not download it and store it somewhere. We give it a name, in this case web react dino, web dino react, installs packages, does some things, and then starts a web server and says, here you go. Which is pretty cool. One command, off we go. That looks a bit like this. So now that we can see the anatomy of a React project, these things are starting to look a bit more familiar than what we saw before. So if you look on the side here, we're starting to see no modules from my npm packages. We're starting to see some source files. We're starting to see package.json, which we all have known and love already. We're seeing the import syntax of new JavaScript to import modules and files and other things. We're seeing classes, which is also a part of new JavaScript, but then extends a lot well into type React. And we're calling a function to return some HTML, which is actually called JSX, long story. And inside that, we can start seeing how we're doing some string replacement and type replacement and other things. So now that we know all the pieces that make this up, we start living in a world where this isn't so scary. Because the problem I had is when I started to build with React in the start of this year, I saw all this and had no idea what it all meant, and no one to explain it to me. So what that looks like in the end is we run npm start, it goes off and runs a whole bunch of scripts that are hidden from you, starts a web server, compiles all the code you've just been given into ES5, and then serves it up on a web page for you to start looking at and making changes to and watching it change live. All within one command. You've run two commands here. npx create react start, or create react app, sorry, and then npm start, and all the other stuff is taken care of for you. So even though you now know about the underlying parts, in 2018 you don't need to actually put them all together unless you find yourself in a much more complicated project. So what do we know? You are no longer a web dinosaur. Lucky you. You can walk into a room and pretend you know how to talk about JavaScript. Like I do. Like I'm doing now. We started with HTML and JavaScript. We moved to a package manager. We used the module bundler to bundle those modules up to things the browser can use. We built the transpiler to support old browsers or to support new features that may not exist in the current standard. We automated that build with task runners, and we ended it with a modern application in React using all the tools we just talked about. Which means you too are now a modern JavaScript developer, and you can have conversations like this with your work colleagues and have the grand experience of being a developer. Now, you don't have to listen to my voice anymore, lucky you. The inspiration for this talk is at that link up there, where it's a very quick rundown of JavaScript for dinosaurs, basically, which is where I got a lot of ideas to talk about this to you guys. The source code that I just talked about is git.io/webdino. My Twitter, @Preecington, still has the slides up from DDD, so if you feel like going to read these for pain, pleasure, or profit, you can do that too. But apart from that, I think I am almost on time for pizza, if I'm lucky. Am I close? I think I'm close. Okay. Otherwise, ask questions, or you can pester me over food. That's fine by me.
So is there any questions?
Well, I wonder how you feel about, side question, how you feel about WebAssembly and Blazor?
I want it to work. I really want it to work. So I'm actually wearing the shirt. I was at Build earlier this year, and I got to chat with the guys who are building Blazor, and they argued that whilst they think it's a great way to get into web dev outside of JavaScript and modern language, they wanted to stress to me that it's still an experimental project. They cannot get Microsoft to even support it as a preview. So they are allowed to work on it in their work time, but Microsoft could kill it at any moment. So for me, personally, I'm not investing in that project until they make it a preview. But as a technology, I'm really excited by it, and I think it could definitely fill a place where there are some gaps, or at least have some competition to JavaScript, which honestly has been a bit unchallenged for a while now. Cool, we're happy. Thank you.